Hello and welcome to the third video in our energy changes topic, which is about how to solve the energy change in a reaction. So, in every reaction, energy is needed to break bonds and energy is given out from making bonds. And today we will be working out whether a reaction is exothermic or endothermic, based on whether it gives out more energy than it started with, or takes in more energy than it started with. So, every single bond has a specific amount of energy that it needs to break the bond, or it gives off when it's created. So, for example, here I have a carbon atom, and a hydrogen atom. Now, to break that bond, I would need 412 joules per mole. But to create that bond, it would give off 412 joules per mole. And the reason for that is energy can't be created or destroyed. So any energy put into something will always be given out of it somehow. Now, this is specific for each one. So if I had a carbon atom and an oxygen atom bonded together, the value would be different of the energy needed to break it and the energy given off when it's formed. Now, I have a question here, and I'll give you some time to answer it. If you want to answer it, just pause the video and work through it. You will need some paper to work through. But there's some information you need first before. So, here's the question. You've got 3 carbons and 8 hydrogens here, all single bonded together, and you've got 5 lots of two oxygen atoms going around together, and they are a double bond. They're double bonded, okay? Now, when the reaction happens, you have 3 lots of 2 oxygen atoms and a carbon atom double bonded together, and plus 4 lots of water molecules, and that's 1 oxygen, 2 hydrogen, single bonded together. Now, the reaction, the energy given off or taken in, is down here. It's all in kilojoules per mole. So these are down here. See if you can work it out, and I'll give you the answers in a minute. Okay, so if you work through this is how you should work through it. So you have 2 carbon-to-carbon bonds, which is 2 lots of 368, which is 736. Then you've got 8 lots of hydrogen-to-carbon bonds, which is 412 kilojoules per mole. And that should give you 3,296. And then you've also got 5 lots of 2 oxygen molecule, an oxygen-oxygen double bond, which is 498 kilojoules per mole, which should give you 2,490. If you add all those together, you should get 6,522 kilojoules per mole. And that will be taken in to the reaction to break all the bonds. Now, here's the energy given out as the bonds are created to form this. So, you've got 3 lots of double bonded oxygen and carbon, which is 2 times 3, so 3 lots of 2 times 532, which gives you 3,192, okay? And then you've also got 4 lots of 2 lots of oxygen and hydrogen bonds, because there are 2 bonds in here, which should, if you do times it together, give you 3,720. If you add those together, you get 6,912, okay? Now, if you should always subtract the product's energy from the reactant's energy. And if you've done that right, it should give you negative 390 kilojoules per mole. Now, if it asks you for the difference, give it as a positive, which would be positive 390 kilojoules per mole. Now, just some pointers before I go. Remember, always subtract the products from the reactants. Don't do it the other way around. Each energy amount is unique to every single bond. So just remember that. And also, if a diagram is given, remember a single line is a single bond, a double line is a double bond. And they're very different. So if I had an oxygen molecule attached to a carbon molecule with a single bond, it would have a different energy requirement than a carbon to oxygen double bond. But if you remember those points, then you should be fine working out. Right, that's it for now. Please subscribe, leave a like, comment if you enjoyed the video. Remember, more subscriptions, more likes, more comments equals more videos. And I hope this was a great help to you, and I'll see you soon.